Hello everyone, how are you all doing? Welcome to IGBits. We train, you learn. Today we shall continue our topic work per energy. We will see some more sums. Alright, without further delay, let's get started. We have our YouTube channel. Visit us at IGBits in YouTube. Please feel free to subscribe and click on bell icon to get the notifications. Your support is very important for us to work together to share many more knowledge sessions across. Okay. Thank you all who are actually being with us and supporting us. This is a great platform that we are aiming for. Thank you all once again. So try this one. This was given as a homework in the last session. A particle of mass 0.1 kg is subjected to a force which varies from distance as shown in the figure. If it starts its journey at x equal to 0 and its velocity at x is equal to 12 is how much? That was an ask. So what is given versus what is asked? So velocity is what is asking. One thing that for sure. So how do we solve this problem? Any clues? By looking at this graph, this is a f and x. Area under curve is what is given as a work done. Clear? So we have to just first look at a work done. The work done is nothing but your energy. Which energy? Probably here kinetic energy. So kinetic energy ka formula of mv square. So work done equal to half mv square, from which you can calculate the v value. Isn't it? Okay, let's try out this one. Area under curve. W equal to area under curve. So how do you solve this problem? This is very straightforward and simple. F, okay, a plus b into h. A plus b means this distance is 12 and then this distance 8 minus 4. How much this one? 8 minus 4 equal to 4. Correct, no? From here to here. So you can put 4. What is height here? 10. This is height. So 16, right? So 8, so 0, 80. 80 joules. This 80 joules is equal to your half mv square. So half mv square equal to 80. F. How much m? 0.1 into v square equal to 80. So v square equal to how much? 80 multiplied by 2 divided by 0.1. This is nothing but 1600. And hence, what would be the v? V equal to root over 1600, which implies 40 meters per second. So that would be your answer. Clear? You like this problem? You should get a clue that area under curve is a work done. Area under this fs curve equal to work done. That's the first clue. And second one, work done equal to half mv square, kinetic energy. These two are the clues for us. Any questions? Well done. Okay, let's look at the next problem statement. How much work must be done by a force on 50 kg body in order to accelerate it to from rest to 20 meters per second in 10 seconds. So basically what is given versus like what is asked. M is given 50 kg. Okay. And initial velocity 0 because you said like rest. Final velocity 20 meters per second is given. Time t 10 seconds. What is needed for us? Work done equal to force into displacement. Now the question is, how do you get it? At least we know there is no force given here, right? So we can translate F into MA. So MAS is needed. M is there. How do you get A? A equal V minus U by T. Agree? So 20 minus initial velocity 0 by 10. This is nothing but 2 meters per second square. So A is also given. What should be done next? Distance is required. So we know S is equal to ut plus half at square. Since the initial velocity 0, you can say this is 0, right? So what is left over is like half at square. Half at square, half into A into T, how much? 10 square. This is nothing but 100 meters. So 52 into 100, right, would be your work done, which is in joules, right? How much it will get it? 10 and 3 zeros, right? Joules. 10 to the power how much? 4 maybe? 4 joules. Good one, right? Let's move on to next problem. Conservative and non-conservative forces. So most of the times, like we will always get a confusion, but understanding the definition very clearly, so that you will be able to distinguish between the conservative and non-conservative. In simple theory, conservative force means like the force under the action of which a body returns to its starting point with the same kinetic energy. So current is a conservation in the conservation of force. The conservation of force is basically like independent of path. So whereas non-conservative means, what happens is like non-conservative force are the forces under which action of which the work done depending upon path. So conservative independent of path, and non-conservative dependent upon path. That is one thing that you have to understand. What that means to me, right? A force is conservative if the work done over any closed path is 0. So spring force, gravitational force, electrostatic force, all these actually kind of a conservative forces. What means is work done, in any direction, in any path, you will be getting like the same value. That is what conservative force means. Let's assume this is a simple example, right? From starting point and ending point, there may be like 3 ways we can, complete the work. So let's say the value of work would be W1, W2, W3. So if the W1 equal to W2 equal to W3, that means this is a conservative force. We are not really depending upon path. Whereas non-conservative forces, we are clearly stating there is a path dependent topic, right? And hence W1, W2, W3 may vary. And hence this is a non-conservative. And simple thing is like when the work done on every possible path is, if at all is equal, we can say it's like a conservative, otherwise non-conservative. As simple as. Okay, in the conservative forces, the forces are recoverable, right? And non-conservative forces, it's not recoverable. I hope you're clear. Example for the non-conservative forces: friction, applied force, push and pull action, tension force. Okay, in case of like conservative force, I think we are reiterating spring force, gravitational force, electrostatic force. Let's look at this problem statement. If W1, W2, W3 represents the work done in moving a particle from A to B along three different paths 1, 2, 3 respectively in the gravitational field of a point mass m, then find the relationship. When you look at a gravitational field, right, G, what is G? G is a conservative force. Conservative force, correct? Work done by the conservative force should be always remain same, right? Because conservative forces are independent of path. That is a clue. And hence our answer would be all work done irrespective of paths remain same in the gravitational field. So your answer 3. Clear? Let's recap. What is meant by conservative force? A conservative force is a force with a property that the total work done in moving particle between 2 points is independent of path taken. Equivalently, if a particle travels in a closed loop, the total work done means the sum of forces acting along the path multiplied by displacement. So total work done by a conservative force is 0. So if the particle traveling in a closed loop, the total work done by conservative force is 0 if it is a closed loop. Otherwise, the work done remains same. In the closed loop, what would be the displacement? Displacement would be 0 if the starting point and ending point are same. Closed path means like initial and final positions remain same, and hence displacement, change in displacement is 0, and hence work done remains 0. That's why we are saying that work done in a closed loop by the conservative force would be the 0. Work done by variable force. In the previous slide, what we discussed is like a constant force. We are not seeing the change in force. We are talking about the magnitude of force and then displacement. In this case, let's assume that the force is keep continuously moving and the changing. In that case, like how do you actually define the work done? So work done is a kind of like the integral sum of all the small portions. When in case of variable force, let's say the force is varying. So what you have to do is like if you can actually put them like a little segmentation, then every integral you have to calculate the work done in this portion, work done this portion, work done this portion. Like that you have to calculate all the individual, the finite work done, and then summing them off to get the total work done. So let's look at work done equal to sigma of f of x dx, and then the value would be from the initial value to final value. Think about that steps. So this is called your total work done in the case of variable. You can rewrite this as this way. Integration of f dot ds would be your work done in case of variable force. If you know the limits x1 I, the max limit and min limit, that is what you are applying. Integration of f dx to limit x1 to x2. So mathematically, you know the formula. So if at all you will be getting like in a graphs, right, and calculating the work from the given graph, what type of graph that you would need to see, f and d, and force into displacement graph. If you look at area under curve, would gives, right, a work. So you have so various ways you can actually calculate the work done from the variable force given cases. Let's look at this problem statement. A block of mass 5 kg, so 5 kg, initially at rest at an origin, right? 0 point acted by the force along the x direction. So means if you can look at the coordinate geometry, in the x direction it's moving from 0 to 4 meters. So some sort of a variable work is what is given. So F equal to 20 plus 5 newtons. Okay. And then the positions are 0 to 1. So x1 equal to 0 and x2 equal to 4m is given. Anything else? So we want work done. So variable force ka variable work done, right? Basically variable force into displacement is gives rise to work done in this context. So we have to use integration from x1 to x2. F dx is what you have to use. Integration from 0 to 4. Force how much? 20 plus 5x into dx. This is what I think finally you have to calculate. Integration for constant we know multiplied by x, constant into x, plus integration for x square by 2, because we know the formulas, right? So integration of 1 dx is nothing but x. Integration of x dx, how much? X into 1 plus 1 by 1 plus 1, right? N plus 1, n equal to 1, so 1 plus 1, so this gives x square by 2. So that's what exactly I'm applying. Now you have to give your limits 0 to 4. Final value 4, initial value 0. So apply 20 into 4, 20 into 4 plus 5 into 4 square divided by 2 is the final value minus initial value 20 into 0 plus 5 into 0 square by 2. This becomes 0. What is left over this much? So 80 plus 5 into 4, right? 4 square. How much? 16. Divided by 2, 8. So this is 40. So it gives rise to how much? 120. What you are calculating? Work. So units joules. Okay. Good one. Any question? Well done. Next, move on. Next slide. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached end of the session today. We shall continue remaining in tomorrow's class. Thank you all who are joined and participated actively in today's class. See you all tomorrow. Stay tuned to next session. Thank you. Have a good day. Bye bye.